PC Calculus, Lesson 8.2, Areas in the Plane. So we've done some of this before. How to find the area between a curve and the x-axis. We just integrate. Just showed that in the last lesson. We integrate the curve, equation of the curve, of course. How about between two curves? Integrate the bigger curve minus a smaller curve. That's a tricky little definition there from the limits where they intersect, or where I tell you to. The problem tells you to. So this is a tricky definition. F of x has to be greater than or equal to g of x throughout the region, closed region. So you got to plug in all those values and see where they take you. This is it for the whole lesson. I'm going to do a lot of examples that talk about special cases and things like that, but I mean, that's it. It's just challenging to envision, to find your limits A and B, and then to do some calculus, but whenever possible, use a calculator and keep your life easy. What's the area of the region between secant squared and sine x? So if I graph these, I see that secant squared looks like this, and sine x looks like this, and pi over 4 is right about here. So here's our region. So what I just said, from 0, and I gave you pi over 4, secant on top, this one is actually fairly easy to integrate. Tangent of x, derivative of cosine is negative, plus cosine of x. Woohoo, we got it right. From 0 to pi over 4. And I'm not going to do all the math. I'll leave that up to you. You'll get root 2 over 2. Units squared. Be aware, I did not put units squared on any of my answer keys. Just know what's going on. So that looks incredibly easy, and generally speaking, once you've set up the whole problem, the integration is not even that hard. And again, I've been doing a lot of this where I just say, you know what? We want the integration from 0 to pi over 4. In this case, a little tricky. 1 divided by cosine x squared parentheses minus sine of x with respect to x. Sometimes this can cycle a little bit, so you have to be careful. And what did we get? We got root 2 over 2, which is 0.704. So that one's a little bit off. My cosine squared's right. Got my limits right. 0 to pi over 4. Secant 1 over cosine. 1 over cosine squared minus sine of x. Interesting. Very interesting. Sometimes it does a little rounding on the calculator, so you got to be careful, but mostly I've had no problems with it. I'm sure I made a mistake there. Another one, find the area of the region enclosed by the parabola, 2 minus x squared, and the line y equals negative x. At this point, you say, well, how the heck am I supposed to know what it looks like? And I say, well, that's why you spent all that time in pre-calc working on this sort of thing. Negative x squared plus 2 is something like this. Y equals negative x is something like this, preferably through the origin. So we must be talking about that. Great, what's the limits? Negative x equals 2 minus x squared. X squared minus x minus 2 equals 0. X minus 2x plus 1 equals 0. Oh, Mr. T, I don't want to have to learn how to factor. Yeah, welcome to the party, pal. Integral. Negative 1 to 2. What's on top? 2 minus x squared minus negative x. Don't have to bother organizing it. Would combine if you can do so. 2x minus x to the third over 3 plus x squared over 2. Negative 1 to 2. I'm actually going to do this one. Let's see if I can do it right. 4 minus 8 thirds plus 2 minus negative 2 plus 1/3 plus 1/2. That's a minus third. I'll distribute that. Negative 8/3 is negative 3, so I get 4 plus 2 is 6, plus 2 is 8. What did I just say? Negative 3, 5. I should get 4.5. Again, units squared. I'm not doing that though. And I feel bad. I want to make sure this works. Math. I think I just made a mistake on the last one. The secant can be a little tricky. It's from negative 1 to 2. 2 minus x squared plus x squared over 2 with respect to x. Better get 4.5. It's good. Felt bad about that last one. And off we go with lots of little tricky problems. Find the area of the region enclosed by the graph. 2 cosine x and x squared minus 1. How the heck am I supposed to know what's going on here? You do all this nasty graphing I just showed you before. 2 cosine of x is just a little bit higher up. X squared minus 1 will be down here somewhere. And we go. It's going to be the integral. Ooh, I don't have my limits. Yeah, I'll get to that. 2 cosine of x minus x squared plus 1. Because of the whole minus thing. And how do we find the points? Well, I go to the calculator and I graph them and I find the intersections. I tried doing solver last time. That caused more problems than it was worth. So 2 cosine of x squared minus 1 graph. Hopefully my graph is not too far off. Clearly I've made a mistake. Gotta wait till it finishes graphing. I'll do my x squared minus 1 at least. I don't think I got my cosine of x in there. I did. Am I in radians? I'm in degrees. And zoom, let's put it in trig. That's a little better. A little slow is the only problem. That's mostly my calculator. Second calc. 5. One curve, the other curve. Get somewhere near the spot. It's got to know what it's kind of approximated from. 1.2654, yada, 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 yada. Use that as our limit. I'm going to do something slick. 2, 0 to 1.26542. 26542. I can do all the calculus I want here. I can int it. I will get, after all is said and done, after multiplying through by 2, because it's symmetric across the y-axis, 4.995. Hey, unit squared. I gotta stop putting unit squared on there because I kept forgetting to do it on my answer key. But anyway, cool stuff. I recommend using that symmetry thing. Getting all the negatives, very easy to make mistakes. Symmetry is a lot easier to work with. You can always check it on your calculator too. Now, I'm not going to do this one, but let's talk about what would happen and how would we do it. Square root of x and x minus 2, which will hit at 2 and come up and slice it somewhere. So how would we do this? Well, we got to divide it into 2. So we'd have a integral from 0 to 2 of square root of x, and then an integral from 2 to the intersection, which I believe, no, I don't know what it is. It's going to be some big, huge, ugly number. We'll call it 4. Yeah, sure, 4 works. Of root x minus x dx. All right. So there's another way to do it. We'll see if you're smart enough to figure it out. I'll come back to it later. But again, we'd break it up into two areas and add them up and get whatever you get. Oh, I'll give you the answer in case you want it. It's total is 10 over 3. Try it on your calculator, see if it works. What if we have something that starts with x? Can we integrate with respect to the y-axis? We could have a couple curves like this. We could have a curve like this. We could have a curve like this. And yeah, it turns out you can integrate with respect to the y. A little tricky figuring out which one's bigger just because we're not used to it, but it's actually not that big a deal. I think we just did this. This looks familiar. So we want to rewrite things. So y equals root x. That means y squared equals x. X equals y squared. Over here we'd have x equals y plus 2. Which one is bigger? Well, that's the same graph we just had. And if you draw vertical lines like this one's always on top. So you would say the integral, I'm not sure what the limits are, of y plus 2 minus y squared. Now y squared actually goes down here, so this would give us a big thing, so I've got to say bottom is 0. And the top, the x was 4, but the y was 2, so you got to make sure you do the y with respect to y. Now I'm going to do it on my calculator just because I want to show you how it's done. And a lot of people say, well, how do you put y in? You don't have to. Again, it's a dummy variable. So math from 0 to 2. And that was y plus 2 minus y squared, x plus 2 minus x squared with respect to x. And we better get 3.3 repeating here. And we do, because we already did this problem. We got the same thing. So, you got to make your choice. Which one do you want to use? Got to figure it out. It's tricky. Which you'd use for the area enclosed by y equals x to the third. Y equals square root of x plus 2. And y equals negative root x plus 2. That's this area here. Well, I mean, you can rewrite it. X equals y to the 1/3. Y squared equals x plus 2 covers that. X equals y squared minus 2. And I think that's probably your best bet. You can do it either way. Run with it and see where it takes you. Break it into chunks if you're going to do it with the y equals. But I think this one's a lot easier. Have to find where those points intersect. So it looks like they are at, ooh, this is a tricky one, 1.793 up here. Sounds a lot like square root of 3. And negative 1 down here. So the integral from negative 1 to 1.793 of y to the 1/3 minus y squared plus 2 dy. One more time, I'll let you do it. You should get 4.215. Last thing, sometimes be real smart about how we do this. The problem we did at the top was the square root and x minus 2. How about we do this? How about we say all of the area minus this area? So we get the integral, and we'll do it with respect to x, of root x dx minus, and this we could do an integral if we want, but I mean, it's just a triangle from 2 to 4 up to 2. It's just going to be 1/2 2 times 2. And we will get, I'll do this one just for the fun of it. 4 square root is 2 is 8 times 2 is 16/3 minus 2, which is 10/3 again. So when you're doing these problems, and I've given you a lot to do, be smart about how you do them. There's lots and lots of different ways to do it. That's a humongous lesson, even though it went relatively quick, so happy mathing with that one.